Let us talk about multi-dimensional arrays in C++. Here is a simple program. I've created an array of size 3 cross 2. It's a 2D array. There are 3 rows and 2 columns. And the values in the first row are 10, 20. Values in the second row are 30, 40. And values in the third row are 50, 60. So we have 3 rows and 2 columns. If we have 3-dimensional arrays, then we'll initialize them using 3 square brackets, and we'll put curly brackets accordingly. Then there will be 3 level of nestings among the curly brackets. Here you can see an example of 3-dimensional array, right? So we have 3 level of nestings, 1, 2, 3. Now how do we traverse a multi-dimensional array? If you have a 2D array, then you need to run 2 nested loops. If you have 3D array, then you need to run 3 nested loops. So we have a 2D array, so we run 2 nested loops, and the typical traversal of a matrix or a 2D array is done this way. We run a loop for every row of the matrix. So we have 3 rows, so we are going to run a loop for every row. And we have 2 columns. So inside this row loop, we run a column loop, and we run it for every column. And we can access this 2D array elements using row index and column index. So in a 1D array, we pass only one index to access the ith element. Here we pass 2 indexes. We want to access jth element in the ith row. So I tells you the row index and j tells you the column index. Output of this program is 10, 20, 30, 40, 50, 60. We have simply traversed through the matrix. Here are some important points about multi-dimensional arrays in C++. First thing is they are stored in row major order. See, a multi-dimensional array is also an array. So every element is stored at contiguous location. So if you created a multi-dimensional array with 6 elements, then all these 6 elements are going to be stored at contiguous locations. Now there are 2 possibilities to store these multiple elements at contiguous location. One is you go row by row. You first store 10, 20, then 30, 40, then 50, 60. This is called a row major order. And the other possibility is you store column by column. You store 10, 30, 60, 50, and then you store 20, 40, 60. This is called column major order. C++ programming language follows the row major order. Let us understand row major order with this example. So if your begin address of this array is 2000, and if an integer takes 4 bytes, then the next element 20 will be stored at 2004. Then the next element 30 will be stored at 2008. Then the next element 40 at 2012. So you can notice this, as soon as the first row finished, your second row started. Then 50 at 2016, 60 at 2020. So this is how elements are stored in row major order. Let's now talk about the second point, which means internal curly brackets are optional. So when you create a multi-dimensional array, you can skip writing these internal multi brackets, right? You can simply declare the same arrays this way also. But this is strongly recommended to use curly brackets, use multi-lines to declare the array to make the code more readable. We could skip the new line character here. We could write everything in the single line here in this declaration as well. Just after comma, we could write 30, 40, but it is recommended to use internal curly brackets and use multi-lines to make the code more readable. However, both multiple lines and internal brackets are optional. So here we have declared this array in one line without internal curly brackets. Now the third point, which is an important point when we pass multi-dimensional array to functions, let's understand the point. The point says that when you are initializing a multi-dimensional array, you can omit only the first dimension. You will have to write all the other dimensions. So if we are initializing a 2D array, then we can omit the first dimension, right? And we'll have to write the last dimension. So compiler automatically figures out that there are 2 rows, so first dimension will be 2. Even if you don't write internal curly brackets, compiler will figure out that there are 2 rows in this matrix. Now talking about 3-dimensional array, we need to write down these two dimensions. We can omit only the first dimension, right? We can't omit this, right? If I remove this 2, then there will be compiler error. If I remove all 2s, then there will definitely be compiler error, right? So there's going to be compiler error if you try removing any more dimensions. So you can only omit the first dimension. So compiler can automatically figure out the first dimension is 2 because there are 2 outer dimension elements in this matrix, right? Then 2 middle dimension elements and then 2 innermost dimension elements. Here is a C++ program to demonstrate variable sized arrays. From C++ 14 standard, C++ allows variable sized arrays. User can write some variables inside the array dimensions. So here is an example. Row, number of rows is m, number of columns is n, and I've used m and n in the array dimensions. Now I traverse this array like normal 2D array traversal, and I assign the values to every element as I plus j. Then I'm printing the array ij matrix. Now please pause this video and try to guess the output of this program. So we are assigning I plus j to every element. We have 3 rows and 2 columns. So there will be 6 elements in the 2D array. And the first row will have the elements 0, 1. For I equal to 0, we'll have j equal to 0 and 1. And the second row will have 1, 2. For I equal to 1, we'll have j equal to 0, 1 plus 0, 1, 1 plus 1, 2. And then for the third row, I will be 2. So 2 plus 0, 2, 2 plus 1, 3. That's what the output of this program is. Let us now talk about more ways of creating multidimensional arrays in C++. The first way is double pointer. So here is a program. We want to create a matrix of size 3 cross 2. We create a double pointer. We call it ARR, although it's a pointer. Now this double pointer is going to point to an array of pointers, right? So we create an array of pointers and make sure that we have the address of this array of pointers in this ARR. Now individual arrays in this array of pointers, they allocate memory dynamically for individual rows. So we go through every array in this array of pointers and we allocate n elements, right? We allocate individual rows and we store their first addresses in array I. So this is how we create a 2D array of size m cross n, right? This creates a 2D array of size m cross n. Now we are traversing this array, we are assigning some values and we are printing these values. So I've simply assigned 10 to every element. M is 3 and n is 2. So we'll get output as 10 6 times. So this is the output of this program. So we have a double pointer which points to an array of pointers, and individual pointers, they point to dynamically allocated array of size n. The interesting thing about this 2D array is we can have individual rows of different sizes. For example, if user wish to create different size rows, we call such arrays as jagged arrays, and we can create a jagged array, right? We do not have to write n here. For every row, we can write different values. For example, I can write I plus 1. This will create first row of size 1, second row of size 2, third row of size 3, and so on. You can choose any value. So that's one advantage of this double pointer setup. The disadvantage of this double pointer setup is it's not cache friendly. When you are creating array this way, and if you traverse your 2D array, they'll not be at contiguous locations. So you will be seeing many cached misses if you make your 2D array this way. One more advantage of this setup we'll see when we talk about passing 2D arrays to functions. With this setup, we can have a function that can take dimensions as arguments and can work for any 2D array. Let us now talk about second method for creating multidimensional arrays. This is very close to the previous method. We create an array of pointers instead of double pointer, and rest of the method is same. So we create an array of pointers, then we individually allocate memory for individual rows. We traverse through all the rows, and for every row we dynamically allocate memory for that row. The only difference with this method and the previous method is, in the previous method, the array of pointers was also allocated on heap. It was dynamically allocated. Here, it's a normal array of pointers, right? It's allocated on the stack. Now, once we created the 2D array, we are now printing it the same way. right? Accessing, modifying it and then printing it. So we'll get the output as 10, 10, 10. And the only difference between the previous one and this one is it's an array of pointers. Earlier we had a pointer ARR which was pointing to this dynamically allocated memory. This time this memory is allocated on the stack and individual pointers have pointers to dynamically allocated memory on the heap. Let us now see method 3 of creating 2D arrays. In this method, we are using STL vector. So we have included vector header and then we have created an array of vectors. So we basically create m vectors where m is the number of rows and individual vectors are going to store contents of individual rows. So once we have created m vectors, we store the contents of individual rows. We traverse through every row. For every row, we push n items into every row. And we are simply pushing 10. We are creating an array of size 3 cross 2 where every element is 10. And then we are printing this 2D array. We can use the same syntax as we use for native 2D arrays here to print this elements from this array of vectors. And the output of this program is going to be 10 6 times. So this is the output of this program. Now let's talk about advantages and disadvantages of this method. Like the previous two methods, this method is also not as crash friendly as simple 2D array method because there everything is stored at contiguous location. Here in this method also, m vectors are created and these m vectors internally allocate dynamic memory, right? And which are at different locations. So this is also not cache friendly. The main advantage of this method over other methods is your individual rows are of dynamic sizes. You can dynamically add and remove elements from individual rows. The previous two methods had different sized rows, but here we have dynamic sized rows. We don't have to fix the row size. We can have as many elements removed and added dynamically because vectors, they take care of this dynamic resizing. The third advantage, like the previous two methods, it's easy to pass vectors, array of vectors to functions than the very first naive method. Let us now talk about method 4. In this method, we create a vector of vectors. The main advantage of this method is number of rows can also be dynamic. We can dynamically add and remove rows in this method. So this method has this additional advantage. Other points of this method are same as method 3. It is not as cache friendly as first method, which is our original method, and it is easier to pass vectors or 2D arrays to functions. We'll talk about 2D array passing in a separate video. Let's see the working of this method with this example. We have created a vector of vectors. Now we are creating individual rows. So this vector represents an individual row. We fill the row by value 10 here. You could write your own logic in different programs. And once we have built individual rows, we add it to our main vector, which is a vector of vectors. Once we have built our whole 2D array, so this code creates your 2D array, right? Once we have built the 2D array, we are simply traversing it, and again we can use the same syntax as a normal 2D array, and output of this program is going to be 10 6 times. So we have talked about multi-dimensional arrays, and we have talked about different methods of creating 2D arrays in this video.